Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on November 9th, 2025, about 2 days ago. The hook is that this paper unveils an open-world multi-agent research ecosystem where autonomous agents read, code, analyze, and publish over long horizons, and those agents deliver new state-of-the-art results across math, biology, and machine learning, even surpassing AlphaEvolve on circle packing. The paper is titled The Station, an open-world environment for AI-driven discovery, and as we will see, the implications for autonomous scientific discovery are significant. Also, the authors shared a GitHub repo. Inside you'll find the full station code with a web interface, example research tasks, and a quick start install using a Conda environment. It includes configs in station data, scripts for local or production deployment, Docker-based evaluation, GPU and debugger settings, and step-by-step usage to launch agents. Alright, Table 1 summarizes how the open-world setup translates into concrete wins across benchmarks. It reports better scores than prior systems in circle packing, batch integration, RNA modeling, neural activity prediction, and Sokoban, which signals broad generalization. For example, the circle packing row shows a higher objective value than AlphaEvolve. The ZapBench row uses mean absolute error, which means the average size of prediction errors, and a smaller value indicates stronger modeling. The method highlights column lists the key design idea behind each win, so listeners can match improvements to techniques. Figure 1 illustrates the station as a circular research world where agents navigate rooms and choose actions freely, which supports long projects without a fixed script. The central research counter functions like a lab desk, where agents submit code and run analyses. The token management room gives agents tools to manage long context, meaning they can compress or retrieve past notes to stay within memory limits. Public and private memory rooms preserve narratives so discoveries can persist across agent lineages. Figure 2 shows how performance improves over station ticks, which means discrete steps of simulated research time. The curves rise fast and then plateau, so breakthroughs arrive early, and the final star marks the best score. The left panel for n equals 32 climbs to a higher primary score and labels the method transitions along the way. The right panel for n equals 26 follows a similar trajectory with its own breakthrough points. Circles mark breakthroughs, and the star indicates the final winning configuration. So, while Figure 2 traced breakthroughs in circle packing, Figure 5 shows how the density-adaptive, batch-aware integration method ranks near the top across single-cell datasets and metrics. The left overall score column places the method just below the artificial positive control, which represents a best case. The blue dataset columns indicate strong, consistent scores. The red metric columns show balanced performance, which matters because integration must avoid overmixing in sparse regions. Alright, 2 takeaways stand out. Persistent, open-world agents with memory and freedom can deliver state-of-the-art results across diverse tasks, and their interactions spark genuinely new methods, not just tweaks. The broader implication is a shift from top-down pipelines to autonomous, long-horizon scientific discovery. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.